So as promised, I'm going to explain to you the worked example of unit 5.9 gas pressure and volume. So I just want to remind you that here again we work with given and asked, and perhaps I need to just turn around my camera. No, I'm not going to do that because it's... So here you can see on the paper next to my book that I've written down a given volume of 0.00020 cubic meters. Basically, in the book they tell you this is 200 cubic centimeters. So remember that for these kind of calculations you have to be able to convert cubic meters to cubic centimeters, and here you see how to do that. 1 meter is 100 centimeters, and then you can multiply 100 by 100 or 100 by 100 by 100, and other way around. 1 cubic centimeters is 1 divided by a million cubic, a million to get to cubic meters. Now back to our worked example, because basically we don't need to convert here. We have given one volume, I call that V1, at a certain pressure, which I call P1, and then they ask you for the volume, which I called V2, at another pressure, which I've called P2. Now the formula you use is PV is constant, and because the temperature is constant, that's also given, so it means that this temperature stays the same, you can write down that P1 times V1 equals P2 times V2. So then you fill that in the calculation. 125 kilopascal times 0.00020 cubic meters equals 100 kilopascal times V2, which you have to calculate, and then you rewrite that like you've learned in math, and it's pretty easy because you can keep V2 on the right and you just divide everything on the left by 100, and then it's actually a pretty easy calculation. 1.25 times that 0.00020 cubic meters, and you find 0.0025 cubic meters, which is 250 squared centimeters, not squared, cubic centimeters, excuse me. So that's how to do these examples. I'll look for some other calculations to practice with, and I just hope that this made it a bit more clear. Good luck.